This is the second video on the Riemann integral, and in this video and also in part 3 I'm going to talk about the area under the curve. And so we start with, we have a function y equals f of x on the closed interval ab. And so we did what we did in the last video. We take our interval ab and we partition it. So we have our x sub 0, which is a, x sub 1, we have n of these, and the x sub n is equal to b. And you can think of n as a large number. So you might think, well, we have 10 of them. Well, we have 1,000 of them. We have 10,000. So the idea is you can think of this as chopping this up into a bunch of little small subintervals. Within each subinterval, you pick a representative point, x sub I star. That x sub I star is allowed to be the left endpoint, and it's allowed to be the right endpoint. I just drew it somewhere in between x sub I and x sub I minus 1. So then we look at the function value here. So this is the point x sub I star, f of x sub I star. X sub I star is your representative point in this interval. Now, what I've done over here is I've taken this part right here and I've blown it up. So this is just a subinterval from x sub I minus 1 to x sub I. Here's our representative point, x sub I star. This is the point x sub I star, f of x sub I star. And we're interested in two areas. First of all, remember, this is area under the curve. So we're interested in the area of the part here that's under the curve. That's what we're calling a sub I. So a sub I is the part that is under the curve between x sub I minus 1 and x sub I. That's what we're calling the a sub I. It's bounded by the vertical line x equal to x sub I minus 1, x equal to x sub I. So these are our vertical lines that are bounding this function, or bounding this region, and it's also bounded by the graph of the function. That's the a sub I. So the a sub I is this piece right here under the graph of the function. And we're going to notice that the area of a sub I is approximately the area of a rectangle. That rectangle has length x sub I minus x sub I minus 1. Right here, this is the width of our rectangle. The height of our rectangle is f of x sub I star. So this is the point x sub I star, f of x sub I star. Need a second parenthesis there. And so this area of this region that we're interested in is approximately the area of this rectangle. This is the width, which is also delta sub I. Remember, delta sub I is x sub I minus x sub I minus 1. And the height of this rectangle is f of x sub I star. And the area of the region we're actually interested in is approximated by the area of this rectangle.